This is Tim Bryce with my column entitled Methodology Design 101. When we introduced Pride as the first commercial methodology for system design in 1971, we never realized the impact it would ultimately have on the industry. It spawned several competitors, both commercially and academically, many of which were various interpretations of the classic waterfall approach as implemented by colleges and CPA firms. Today, many companies avoid the use of methodologies as they are considered bureaucratic paper mills. In some instances, this is true. But the fact remains you cannot build anything of substance, be it a system or otherwise, without a methodology. The question then becomes how to construct a methodology suitable for your company or a given project. To this end, I offer this tutorial on designing methodologies. First, if we lived in a perfect world, there would not be a need for managers. Everyone would know precisely what their assignments were and would successfully accomplish them on time and within budget. However, the reality is we live in an imperfect world. We as human beings make mistakes, we work on multiple assignments concurrently, and require guidance. It must be recognized from the outset that project management does not come free, nor does it come naturally to people. Traditionally, the typical approach to project management has most often been to find a project manager, provide resources, and then give them an assignment with no direction as to how the project will be conducted or controlled. Under this approach, the success or failure of the project is dependent on the abilities and experience of the project manager and how well the manager can organize and train the project team, plan the project, estimate, and so on. Consequently, there is significant trial and error in the process. This approach usually results in a unique method for the particular project because it reflects the thinking of the project manager. Different managers use different techniques and ideas. In other words, it is quite common for systems projects to lack uniformity and consistency. Thereby, workers have to learn the methodology with each new project assignment. Another common approach used was the brute force approach. Simply stated, I don't care how you get the job done, just have it completed by such and such date. This approach shows a lack of sensitivity to the complexity of project management. There is more to project management than maintaining costs and time schedules. It is the process of applying resources to a defined goal and attaining this goal within time and cost objectives. Fundamentally, it is a people-oriented function as opposed to administrative or clerical function. Project management, therefore, is not a tool or technique, but rather a philosophy of management. Project management is to a methodology what production control is to an assembly line. Without the assembly line, production control is a useless exercise. Conversely, without a methodology, project management is useless. The ultimate test of a methodology is if it can operate independent of project management. The two are not synonymous. Although they work in concert, there are distinct differences. Whereas a methodology dictates what work is required, project management controls the application of work. Just as an assembly line can produce a product without production control, a methodology can produce a product without project management. Therefore, a methodology is independent of project management, but project management is totally dependent upon a methodology. A project is an application of effort towards prescribed objectives through the execution of a defined sequence of events. All projects have a life cycle, a beginning for planning, a middle for execution, and an end for review. Each project has a unique scope, set of objectives, and defined sequence of events. The methodology thereby is the roadmap for a project. It defines organization and direction. For any methodology, there should be a conceptual foundation explaining the rationale for its structure. In the case of Pride, we introduced the concept that a system is a product that can be engineered and manufactured like any other product. This was a revolutionary idea at the time, and still is to many systems developers today. Nevertheless, this concept allowed us to use a hierarchical product structure to decompose a system top-down and test and install bottom-up. This permits us to design and build the various parts of a system in parallel and concurrently, just as engineering and architectural projects are conducted. Pride was a departure from the conventional wisdom that systems were developed using a linear approach, such as that found in the waterfall approach. Next, let's talk about work breakdown structures. In order to perform project planning, we must resolve the following questions. Number one, what is the scope of the project? The scope must state the project's objectives and the parts of the organization involved, both directly and indirectly. Number 2, what are the steps required to meet the project's objectives? Performing work in a logical sequence gives direction to the project. The inability to do so results in lost time and effort. Therefore, not only do the required steps in a project need to be defined, but the precedent relationships between work steps must also be defined. Number 3, what are the deliverables and benchmarks of the project? In order to verify a particular project task has been completed, it is necessary to substantiate that all aspects of the task has successfully been executed. An impartial and objective mechanism checking the completeness of tasks is necessary. It is important to demonstrate tangible results from our project efforts in the form of accomplishments and deliverables. Any task that does not result in a reviewable or tangible result is an unnecessary step that should be eliminated. Number 4, what resources are required to perform the work? Assigning the correct resources to the appropriate work steps is a critical factor in every project. By properly defining the work steps and the benchmarks, it is possible to clearly identify the skills required to execute the steps. Resources with appropriate skills and availability can then be assigned to the project task. A work breakdown structure is a hierarchy. All projects have a structure depending on a methodology used. The methodology defines what is going to be produced. It can be as simple as one step or as extensive as several phases involving multiple activities and tasks. The methodology represents the selected approach for implementing a project. It is structured into a hierarchy consisting of one or more phases of work. A phase represents a major key event or milestone in the project. Each phase consists of one or more activities representing sub-events required to meet the milestone, and each activity consists of one or more operational steps or tasks representing the individual actions to be taken in the project. Each phase, activity, and operation of a methodology should produce a reviewable result, a work product, to substantiate completion of assignments. Otherwise, a methodology becomes a meaningless series of tasks. In systems development, such deliverables include such things as reports, for example, feasibility studies, design documents, program source code, and executables, database structures, test data, test results, project audit, and so on. If the deliverables haven't been produced, we can conclude the work step wasn't performed. If the deliverable was produced, there should be criteria to evaluate, therefore providing a mechanism to review and correct if necessary. Bottom line, for each work step, we should define what is its purpose, what will it produce, its deliverable, what is the criteria for substantiating completion, and who will perform the work. The level of detail required to perform a project is ultimately left to the discretion of the project manager. If a simple project, perhaps the manager will only define a phase with a few activities. However, if a project is large and complex, the manager may wish to define and manage at the operational level. Next, let's talk about precedent relationships and their dependencies. Up to this point, we have only defined what work is involved, not its sequencing. A methodology defines not only the various units of work, but also dependencies between the work steps. Such dependencies are referred to as precedent relationships. Project work steps may be conducted either sequentially or in parallel, alluding to branching. Precedent relationships define what work steps precede and succeed a single work step. Precedent relationships can be defined between work steps in the same level of the methodology structure. This means project-to-project relationships, phase-to-phase relationships, activity-to-activity relationships, and operation-to-operation relationships. This brings up 2 points. Progression between project work steps at the same level cannot proceed until the subordinate levels are fulfilled. This means you cannot move from one project to another until all the phases from the first project have been performed. Nor can you move from one phase to another until all of the activities from the first phase have been performed. Nor can you move from one activity to another until all of the operations from the first activity have been performed. Next, you cannot define lower level work steps until you have first defined the higher levels. In other words, you must define phases before you define activities, before you define operations. The one exception to this is a phase to project relationship, where a separate project can be activated pending upon completion of a phase. This can be demonstrated by separate PRIDE ISIM and PRIDE DBEM projects. Although project-to-project and phase-to-phase relationships are permitted, they are uncommon. Most projects will only show interdependencies, such as phase-to-phase, activity-to-activity, and operation-to-operation. Although branching, or parallelism, can occur at any level in the methodology, the project manager will typically find less need for branching at the lower levels of the methodology structure. This means phases are more apt to branch than operations. More operational steps within an activity are performed serially or sequentially. To expedite the development of methodology structures, we have provided a methodology definition worksheet, which is used to define the work breakdown structure and precedent relationships. Let's summarize with methodology criteria. In order to effectively organize a project, it is important to recognize the basic elements of methodology. The mandatory requirements are, first, a defined work breakdown structure consisting of a series of work steps and various levels of abstraction, such as phases, activities, and operations. Second, it defines the project functions responsible for performing the various work steps. And third, defines the project dependencies, the precedent relationships between work steps. Without these mandatory requirements, a methodology is illegitimate and should be referred to as something else. Optional requirements include, first, have a single phase to initiate a project and a single phase to conclude it. Multiple starts and multiple ends are not desirable from a management point of view. 2. The methodology structure should be based on reviewable work products to verify completeness. If the methodology is not defined accordingly, the dance of the fairies phenomenon will ensue. Number 3. The methodology structure should be reusable on multiple projects. Number 4. Provide for both sequential and parallel project execution. Number 5. The methodology structure should accommodate a product structure, thereby allowing parallel processing. 6. Although these latter requirements are not mandatory, they are highly desirable features and have been incorporated into the methodologies in PRIDE. Project planning is made simpler by the existence of standard methodologies, such as PRIDE, which includes defined phases, activities, deliverables, precedent relationships, and the functions to perform the work. This saves time in project planning and brings consistency to projects of like kind. Then again, system designers and programmers tend to resist the discipline of a methodology. As such, the old adage is true: if you don't know where you're going, any road will take you there. However, it is inconceivable to build anything of substance without a methodology. It is how bridges and skyscrapers are built, automobiles, aircraft, consumer electronics, highways, even medical care and food service. Come to think of it, just about everything requires a methodology. So what makes systems designers and programmers special? Friends, keep the faith. This is Tim Bryce in Palm Harbor, Florida. Follow me on the internet at timbryce.com.